Hello students, how are you all? I hope you are doing well. Today we are going to discuss chapter 15, Light. Let's warm up. Have you ever thought why are not able to see the things during night time that we see well at daytime? Do you know what enables us to see the things around us? So students, these are some questions you have to discuss these things in your class. Here, let's know about light, spherical mirrors, lens, colors of light. So student, these are the topics we are going to discuss in our chapter. The first we have light. Light is a form of energy. When a beam of light enters a dark room through a crack or a tiny hole, it illuminates things that lie in its path. The beam of light appears to travel in a straight line. The same is true about the beam of light from a torch, a lighthouse, and the headlamps of vehicles. So we can say that light travels in a straight line. So students, आप सबको पता है कि light एक straight path में जो है travel करती है. And the second thing we all know that अगर कोई dark room में light जैसे enter करती है तो हमें दिखाई देता है उसके path में जो भी चीजें होती हैं वो सब चीजें क्या हो जाती है, हमें दिखनी start हो जाती है. Now we have rectilinear propagation of light. Light travels in a straight line. This is known as rectilinear propagation of light. Let us show this property with the help of an activity. So students, here we have an activity. Activity 1. Aim. To demonstrate the light travels in a straight line, note activity to be performed under adult supervision. So students, you have to perform this activity with the help of your teacher. Here we have things required: a sheet of paper, a candle, and a matchstick. Method: make a pipe using the sheet of paper and light the candle. Point one end of the paper pipe towards the candle. Bring your eyes closer to the other end of the pipe and try to look at the same flame through it. Record your observation. The next step we have: bend the pipe as shown in B and try to look again at the flame through the pipe. Record the observation again. Here we have observation. You will be able to see the flame through the straight pipe but not through the bent pipe. Here we have explanation. When the pipe is straight, it provides a straight line path for the light beam to travel from the candle to the eye. This makes the flame visible. When the pipe is bent, there is no straight line for the light to travel from the candle to the eye. Therefore, the flame is not visible. Here we have conclusion. The above observation clearly shows that light travels in a straight line in a uniform transparent medium like air. This property of light is called rectilinear straight line propagation movement. Here we have some pictures. Look here, A and B. Bent pipe and straight pipe. Now students, we have reflection of light. If we throw a tennis ball at a wall, the ball bounces back. This means that when the tennis ball strikes the wall sends it back. Similarly, when light falls on the surface of an object, the object sends the light back. The process of sending back the light rays which fall on the surface of an object is called reflection of light. तो स्टूडेंट, अगर हम रिफ्लेक्शन की बात करें तो रिफ्लेक्शन क्या होता है? जब रेज ऑफ लाइट आकर किसी ऑब्जेक्ट से टकराती हैं एंड देन दे गो बैक, जब वो वापस चली जाती हैं, दैट इज रिफ्लेक्शन ऑफ लाइट. नाउ वी हैव एंगल ऑफ इंसिडेंस. द एंगल formed between the incident ray and the normal ray is called the angle of incidence. Angle of reflection. The angle formed between the reflected ray and the normal is called the angle of reflection. Look here student, look at this picture we have. Here is a mirror. It is angle of incidence and it is angle of reflection. Now students, we have image. It is an impression of an object formed due to reflection of light in a mirror is called image. It is of two types as explained below. Here we have real image. The image that can be formed on a screen is called real image. It is formed due to intersection of incident and reflected rays. It is always inverted. Example, the image formed in the screen in a cinema hall. So student, ये क्या है? Real images होती है. Now we have virtual image. The image that cannot be formed on a screen is called virtual image. It appears to meet at a point. It always erect. Example, the image formed by a plane mirror. So students, अगर हम virtual image की बात करें तो best example आप देख सकते हैं. आप लोग रोज शीशा देखते हैं, शीशे में जो आपको अपनी इमेज दिखाई देती है, that is virtual image. Now we have image formed by a plane mirror. Plane mirror is a flat glass surface which is polished silver on its back face. So students, here we have some activities. Now we are going to read these activities, then we are going to read characteristics of image formed by a plane mirror. So first we have an activity, activity 2. Now students, here we have an activity, activity 2. Stand in form of plane mirror and raise your left hand. See it in the mirror. It appears to be your right hand. You will observe that in the mirror, the right hand appears left and the left hand appears right. The property of light in which left appears right and right appears left is known as lateral inversion. So student, ये property क्या है? Lateral inversion है और I think ये आप सब करके देख सकते हैं. It is very easy. Now we have a next activity, that is activity 3. Place a lighted candle in front of a plane mirror. Now move the candle to different positions in front of the plane mirror. Observe the image in each case. We will observe that we move the candle towards the mirror. Image also moves towards the mirror and it is also of the same size as the object. It means that the image formed in plane mirror is of the same size and the image formed is always at the same distance as the object is placed in front of it. So students, ये क्या आपको दिया गया इस एक्टिविटी में? आपको एक कैंडल लेनी है, उसको ब्लो करना है और मिरर के सामने रखना है. फिर आप मिरर से जैसे जैसे उसकी डिस्टेंस चेंज करेंगे वैसे वैसे आपको ऑब्जर्व करना है. आप ऑब्जर्व करेंगे, आपको कैंडल सेम दिखाई देगी इमेज में, सेम शेप की, सेम साइज की, एंड जिस डिस्टेंस पे आप कैंडल को रखेंगे मिरर से उसी डिस्टेंस पे आपको क्या दिखाई देगी? आपकी इमेज. So that is the thing कि वो कैसे इमेज को फॉर्म करते हैं. Now we have some characteristics of image formed by plane mirror. The first we have, when we look into the mirror, the image of any object appears to be behind the mirror. In general, we can say that the image formed in a plane mirror is behind the mirror. The second we have, the image formed in a plane mirror is virtual. The image formed in a plane mirror can be received on a screen. The image in a plane mirror is of the same size as the object. It is neither smaller nor bigger than the object. The image formed in a plane mirror is erect or upright. It is same side up as the object. The image formed in a plane mirror is at the same distance behind the mirror as the object in front of the mirror. The distance of an image from the mirror is equal to the distance of an object from the mirror. And the last we have, the image formed in a plane mirror is laterally inverted. So student, these are some properties like जो इमेज है वो सेम साइज की बनती है एंड द सेकेंड थिंग जो इमेज की डिस्टेंस है और जो ऑब्जेक्ट की डिस्टेंस है वो सेम डिस्टेंस पे होते हैं मिरर से. आपकी इमेज जो है प्लेन मिरर में वो लेटरली इन्वर्टेड होती है. सो दीज आर सम कैरेक्टरिस्टिक ऑफ इमेज formed by a plane mirror. Now students, we have uses of plane mirror. Some important uses of plane mirror are as follows. They are used as reflectors in solar cookers. They are used for making kaleidoscope and periscope. Plane mirrors are used as looking glasses. They are used to record observation in some scientific instruments like barometer. So students, these are some use. Now we have spherical mirrors. If the reflecting mirror is a part of a sphere, then it is called a spherical mirror. Now we have types of a spherical mirror. Spherical mirrors are of two types, concave mirror and convex mirror. Here we have first concave mirror. A concave mirror is called a converging mirror. If a set of parallel rays fall on a concave mirror, they reflect and meet at one point. Hence, it is called a converging mirror. And the point at which the rays meet is called the focus of the mirror. The distance from the focus to the mirror is called the focal length. Let us learn about the image formed by a concave mirror. So students, concave mirror जो है वो converging mirror होता है और concave mirror पे जब light reflect होती है तो जो reflected rays हैं वो किसी एक point पे जाके meet करती है, जहां वो मिलते हैं that is focus, और mirror से focus के बीच की जो distance होती है that is focal length. Now look at this picture we have. Now students, look at this picture. We have concave mirror and this. Here is principal axis, polished surface, pole, focus, and this is reflecting surface, and this is holosphere. So student, these are the some terms related to concave mirror. Now come to the next, we have convex mirror. If the inner surface of the slice from a hollow sphere of glass is polished silver and the outer surface behaves as a reflecting surface, it is called a convex mirror. A convex mirror is also called diverging mirror. So students, convex and concave is just opposite. Look at this picture, we have convex mirror. Here it is reflecting surface, then pole, then polished surface, then hollow sphere and principal axis. Now, parameters of spherical mirrors. Here we have parameters of spherical mirrors. First, pole. The geometric center of the spherical mirror is called its pole. It is denoted by capital P. Then we have center of curvature. The center of the hollow sphere from which the mirror has been taken out is called its center of curvature. It is denoted by capital C. Then we have principal axis, a straight line passing through the pole and the center of curvature of a spherical mirror is called its principal axis. So students, now you get it, what is principal axis, what is center of curvature. Now we have radius of curvature. The distance between the pole and the center of curvature is called the radius of curvature of the spherical mirror. It is denoted by capital R. Then we have focus. The midpoint of the pole and the center of curvature of the spherical mirror is called its focus. It lies on the principal axis and is denoted by capital F. Then we have focal length. The distance between the pole P and the focus F of the spherical mirror is called the focal length of the spherical mirror. It is denoted by small f. Now students, we have image formed by concave mirror. The characteristic of image formed by concave mirror are given below. So students, here we are going to read about the characteristics of image formed by a concave mirror. Here we have image can be real or virtual depending on the position of the object. The size of the image can be smaller or enlarged. Real image is formed in front of the mirror while virtual image is formed behind the mirror. The nature and ray diagrams of image formed by concave mirror of an object placed at different places are as follows. So students, nature of image depend upon the position of the object. Here we have a table, image formed by concave. Here we have a table, image formed by concave mirror for different positions of the object. So students, look here, we have position of the object, position of the image, size of the image and nature of the image. Here, position of the object at infinity, position of the image at focus, and size of image highly diminished, point sized, nature real and inverted. Then we have again position of the object beyond C, position of the image between F and C, size of the image diminished, nature real and inverted. Now come to the next, we have at C, position of the object at C, position of the image at C, size of the image same size, nature of the image real and inverted. Now come to the next students, we have position of the object between C and F, position of the image beyond C, size of the image enlarged and nature of the image real and inverted. Now students, position of the object at F, position of the image at infinity. Then we have size of the image highly enlarged, then nature of the image real and inverted. Now come to the next, we have students, position of the object between P and F, position of the image behind the mirror, size of the image enlarged and nature of the image virtual and erect. So students, here we have a table and you have to learn it. According to this, the formation of image is held in concave mirror. Now look at these pictures. We have image formed by concave mirror for different positions of the object. So students, you have to draw these diagrams in your notebook. Now students, we have uses of concave mirrors. Concave mirrors are used for many purposes. Some of the important uses are: concave mirrors are used as reflectors in torches, headlights of vehicles such as cars, scooters, buses, trucks, trains, engines, etc. to get a strong straight beam of light. Then, concave mirrors are used as saving mirrors by man to see an enlarged face. Women also used concave mirrors as makeup mirrors to see an enlarged image of the face. Then we have doctors use concave mirrors to produce a parallel beam of light for examining body parts such as eyes, ears, nose and throat. Concave mirrors are used by dentists to see an enlarged image of teeth. Now students, we are going to read image formed by convex mirror. The characteristic of image formed by convex mirror are as follows. Here, the nature of image is virtual and erect. The size of the image is smaller than the size of the object. The position of the image is behind the mirror. The nature and ray diagrams of image formed by convex mirror of an object placed at different places are given ahead. So students, ये कुछ क्या है, characteristics हैं, जैसे कि वो small होती है size में and वो virtual और erect image form होती है convex mirror में. Here we have a table, image formed by convex mirror for different positions of the object. Look here students, position of the object, position of the image, size of the image, nature of the image. Here we have position of the object at infinity, position of the image behind the mirror at focus, size of the image highly diminished, point sized, and nature of the image virtual and erect. Then we have position of the object between P and infinity, and position of the image behind the mirror between P and F, size of the image diminished, nature of the image virtual and erect. Now students, look at these pictures. We have A, when the object is at infinity. Then come to the B, we have when the object is between infinity and pole of the mirror. And these are the pictures, images formed by convex mirror for different positions of the object. Now students, we have uses of convex mirrors. Some important uses of convex mirrors are as follows. Convex mirrors are used as rear view mirrors on the sides of the driver's seat in the vehicles. Now students, we have check and mate. As we already read about these things, so you have to do it by yourself. Convex mirrors are used as a distance view mirrors at the turning points of the narrow staircases. Convex mirrors are used for vigilance at big shops and warehouses. Here, look at this picture. Convex mirror is used in cars. Now we have lens. Do you know you are able to read these lines? It is with the help of a transparent lens in your eyes, which helps to form image on your retina. You may have seen lenses often without realizing it. The spectacles, contact lenses, and magnifying glass, etc. contain lenses. Let's learn what are lenses and how they work. A lens is a transparent curved surface made up of high quality glass or transparent plastic. So students, अगर हम लेंस की बात करें तो लेंस क्या है, हमारी आईज में भी लेंस है जिसकी वजह से हम क्या कर पाते हैं, इमेज देख पाते हैं या ऑब्जेक्ट्स को देख पाते हैं. Now we have types of lenses. Lenses are of two types, convex lens and concave lens. Here the first we have convex lens. It is a thicker in the middle than at edges. It is thicker in the middle than at ends. A convex lens is also called a converging lens as it converts the rays of light falling on it. So student, convex lens is converging lens. Now we have concave lens. It is thicker at the edge than in the middle. A concave lens is also called a diverging lens as it diverges the rays of light falling on it. Based on their converging and diverging abilities, lenses are extensively used in spectacles. So students, lens को हम use करते हैं उनकी ability के according वो diverging है या फिर converging है. Now, why do lamins and decorative marbles kept in a circular container of water appear to be larger? Lamins and decorative marbles kept in a transparent circular container of water appear bigger than the actual size because of magnifying action of water behaving as a convex lens. So students, convex lens क्या करता है, किसी भी ऑब्जेक्ट को आपको मैग्नीफाई करके शो करता है. Okay, now look at these pictures. We have convex lenses and concave lenses. Do you know? The lens present in the human eye is a convex lens made up of transparent jelly-like material. So students, human eye में convex lens present होता है. Now we have image formed by convex lens. Convex lens forms different types of images depending on the position of the object. Here we have image formation by convex lens for different positions of the object. Look at this table. We have position of the object, position of the image, relative size of the position of the image, and nature of the image. Now students, first we have at infinity, position of the object, position of image at focus f2, size of image highly diminished, point sized, nature real and inverted. Now come to the next. We have position of the object beyond 2f1, position of the image between f2 and 2f2, and size of the image diminished, nature of the image real and inverted. Now again, position of the object at 2f1, position of the image at 2f2, size of the image same size, nature of the image real and inverted. Here, position of the object between F1 and 2F1. Position of the image between 2F2. Nature, size of the image enlarged, and nature of the image real and inverted. Now come to the next we have students. So position of the object at focus F1, position of the image at infinity, size of the image infinitely large, highly enlarged, and nature of the image real and inverted. Now come to the next we have position of the object between focus F1 and the optical center O. Position of the image on the same side of the lens as the object. Size of the image enlarged, nature of the image virtual and erect. So student, this is a table, that's how image is formed. Now look at this picture we have when the object is at infinity, when the object is beyond 2F1, when the object is at 2F2. Then when the object is in between F1 and 2F1, then between F1 and 2F2, when the object is at focus F1, when the object is in between focus F1 and optical center of the lens. Look here, these are images formed by convex lens for different positions of the object. Now we have uses of convex lenses. Uses of convex lenses are given below. Convex lenses are used in cameras of all types except in a pinhole camera. Convex lenses are used in telescopes and microscopes. Convex lenses are used in spectacles to help people to see nearby things clearly. Look at these pictures we have. Convex lenses are used in telescopes and microscopes. Now students, we have image formed by concave lens. Concave lens forms different images depending on the position of the object. Here, image formation by concave lens for different position of the object. Here, position of the object at infinity, position of the image at focus F1, size of the image highly diminished, point sized, nature of the image real and inverted. Then, position of the object between infinity and optical center O of the lens, position of the image between focus F1 and optical center O, size of the image diminished, nature of the image virtual and erect. Now look at these pictures. A. When the object is at infinity. B. When the object lies between infinity and optical center of the lens. These are the images formed by concave lens for different positions of the object. Here we have uses of concave lenses. Uses of concave lenses are given below. Concave lenses are used in Galileo's telescope. Concave lenses are used in spectacles to help people to see the distant objects clearly. Here we have the pictures of Galileo telescope. Now students, we have colors of light. Take a transparent ruler and hold it in sunlight. Adjust its position a little till you see a hue of various colors. Notice that while sunlight splits into 7 different colors, you can also see these 7 colors in the sky in a rainbow formed after it has rained and the air is still laid with moisture. The sunlight on passing through the droplets of rain forms a band of colors which we call a rainbow. So student, आप सबको पता है, आप सबने रेनबो देखा भी होगा. जब सनलाइट किसी ड्रॉपलेट से, वाटर ड्रॉपलेट से पास करती है तो वो किसको फॉर्म कर देती है? रेनबो को. नाउ लुक एट दिस पिक्चर्स. वी हैव 7 colors of white light. This phenomena of splitting of white light is called dispersion and the band of colors is called a spectrum. The 7 colors in the spectrum of white light are violet, indigo, blue, green, yellow, orange and red, known as Vibgyor. So students, इस 7 color के band को हम spectrum बोलते हैं और इसको हम define कैसे करते हैं? Vibgyor. Here we have Newton's color disk. Newton's color disk is a disk of cardboard or metal which is divided into 7 sectors which are painted in colors of Vibgyor. When the disk is rotated very fast, it appears almost white. This is because the image of each color on the retina does not get erased before the image of the other color forms on it due to the fast movement of the disk. This phenomena is called persistence of vision. The reason why the color on the disk does not appear exactly white because the colors on the disk are not exactly like the colors in the natural spectrum of light. Now students, look here, we have colors of white light, rotating disk. This is Newton's disk. Now students, what we learn in this chapter, we are going to discuss it in a nutshell here. Light enables us to see the beautiful world around us. Light travels in a straight line. Bouncing back of light on a striking highly polished surface is called reflection of light. The ray of light falling on the reflecting surface is called the incident ray. The ray of light after the reflection from the surface is called the reflected ray. The angle formed between the incident ray and the normal is called the angle of incidence. The angle formed between the reflected ray and the normal is called the angle of reflection. The image that can be formed on a screen is called real image. The image that cannot be formed on a screen is called a virtual image. Plane mirror is a flat glass surface which is polished silver on its back face. When the reflexive mirror is a part of a sphere, it is called a spherical mirror. Now students, we have some keywords here. Real image, an image that can be formed on a screen. Virtual image, an image that can be formed on a screen. Virtual image, an image that cannot be formed on a screen. Concave mirror, a curved mirror with its outer side polished silver. Convex mirror, a curved mirror with silver polish on its inner surface. Then magnifying glass, convex lens used to magnifying small objects. Thank you students. We will meet again in the next chapter. Till then, revise what we learned today.